Now, today I'm going to pass out accounts here on at least 2 machines. We'll probably get a third one a little later down the line. And you're going to need to be able to log on to these machines to find out your proper UID, as we'll see today when we look at the next portion of the lab. So I've already ambushed a few of the people in the lab, and so a few people have already collected their passwords. But basically, you're going to be getting a little slip of paper, and it's going to have your username on Rohan on it, and your username on Legolas. And there's a third one in here, which is going to also give you the common password, the gibberish password for both those accounts. And to get your account, you basically have to acknowledge that, yes, you've read the CX470 statement, which means you're going to do your own work and stuff like that, except for the portions that you're supposed to do as an entire group. So I'm hoping to stop a bit early today so that everyone has a chance to pick up their passwords. And yes, I'm still horribly sick, so don't come too close to me. All right. All right, any other issues that I don't already know about that have happened in the lab so far? I think we've had like 3 groups try, and 2 groups are moving along at this point. All right, so we're about to get to the stage where we can try to SSH into these machines. By default, Mint is set up to not allow incoming connections like this. So there's no web server available there to begin with, no SSH daemon available. I'm not even sure that it delivers mail by default to begin with. Okay? So we need to arrange for that to happen and change, start up a server and change it to behave the way that we want. Now, on different flavors of Unix, often there's some little GUI interface that you can use and go click a few buttons to get some of the things that you want to have happen. And all they really do is change the underlying configuration files, and they seem to think that makes it easier for people to work with. But if you know how to change the configuration files yourself and know what's really going on here, then you don't have to worry about 12 different GUI interfaces from 12 different Linux vendors. You know how to fix things. So we're most of the time not going to be using the GUI parts for one particular vendor because it's not the same GUI when you go over to another flavor of Unix. But we'll instead see what's going on in the underlying files and get an idea of what's actually happening. So we're going to try to do this little demonstration here live, and again, part of it is to give you a little bit of insight into how VI works, and we'll also talk about what's actually going on in these particular files. Okay, so again, if you try this, you'll find out that it isn't going to work for root. If you SSH over to your own host at this point. We're going to change a few things in the list here, and those are down under etc SSH. The etc directory here, short for etc essentially, is where most of the configuration files live. Not necessarily right in SSH, but often there's a whole bunch of subdirectories. Way back when they were sort of all underneath etc, but now there's just so much stuff to configure they've made a bunch of subdirectories there. And the stuff associated with SSH is in the SSH directory, not too oddly. Right, and so I sort of set up a similar thing over here on Rohan, and this is supposed to simulate what you would find in the etc SSH directory. So I just copied this off of one of the machines. So there's an SSH config file here, which determines what the client does by default. And there's an SSHD config here, which determines what the server is supposed to do by default. And the one guy that we want to edit is this SSHD guy here. Right? So there's one file that begins with an M. Most of them begin with SSH underscore, but one of them begins with SSHD. Right? And that turns out to be the one that we want to get to in this lessening. All right, so whenever we change a startup file, we kind of want to remember what used to be there before we, in case we screw it up. That way we can always put things back. So I mentioned last time there is a better way to go about doing this, but but for now, we're not going to learn about RCS in this lab, but in the next lab. So we're going to copy this into this into the original version there before we change anything, do a diff of those two things, and I think I discussed this last time. We're going to replace CP with VIFF, which means it's going to run that command, and since there are no differences, you see no output because there are no changes. And then we're going to VI the file. We're going to VI the SSHD config file here, and normally that would drop you onto line 1 of the file. But the particular line that you want to mess with is the one that begins with the word permits. So you can say stuff like VI plus 13, and that would take you to line 13, or plus 23, and that would go to line 23, or you can give it a pattern. Tell it to search for the first line that begins with the word permit with these particular capitalizations. Right? And then that's where you'll wind up in VI if you do that. Right? And then we make a couple of changes there. And then we do a diff again to see if the changes are what we expected. Right? So it's always a good idea to look at the original compared to what you have, because maybe somehow you threw away a line that you didn't mean to throw away. So the differences ought to look like what you expect them to. And the diff command here will tell you different things. In this case, this is a change command. Sometimes you'll just see a delete command that, hey, one guy looks like the other file except line 13 got deleted, for example. Or it looks like the other file except now we have added something just below line 23. Right? So you might see an A here, or you might see a D there, or in this case, things changed around this one particular spot in the file, around line 28. What used to be line 28 has now become two different lines. Right? And you get to see what's on the left-hand one as opposed to the right-hand one. So the original one just had a line 28, and that's been replaced by line 28 and a new line, which will be numbered 29. So it's one line longer than it used to be. Okay? And the actual differences are on the next page. Right, so what was in the original file was this thing. It lets you log in as root without needing a password. And we don't really want to have that condition on there. If you look in the man pages and whatever, the condition we really want is to just say yes, let them in without a password. So what we want to do is comment out that line in many, many different configuration files, but not all of them. A pound sign means from here to the end of the line, ignore whatever we've got there. It's supposed to be a comment. So we want to remember what we used to have there, right, but comment it out, and then put in the line that we want, which turns out to be this one. So what's actually happening here was basically about 5 things. We were going to copy the files. Once we get into that directory, we're going to make a copy of the file, do a diff on it, do a VI, and do another diff. Okay. So let's see how long that actually takes to accomplish here. Those 5 things with those changes. All right, so I'm going to do a copy sshd config to sshd config.orig, and I'm going to replace the CP with a diff, and then I'm going to vi plus / caret permit on almost that guy, but that guy, and now I'm going to yank, put a pound sign there, and change this to a yes, and do the diff again. So, I don't know, 30 seconds or so that we did there, those 5 different commands. And so it gives you some idea why, if you don't VI, et cetera, that can be kind of impressive in a work environment, because see you doing these things and doing them almost immediately, gets you noticed. All right, so no one knows what I actually did there, so we have about a page of stuff here which talks about how this actually works. There is still something wrong with this projector. It always wants to keep freezing the screen and giving me that stupid little line there. All right, So, what actually happened when I was fiddling with the keyboard here? Well, the first thing we wanted to do was that copy. So I did a copy, and I just typed the S, because some of the commands, some of the files started with an M, for example. So I typed an S, and then I did a tab there. And it couldn't get a unique file out of that, but all the ones that started with S started with SSH. And you might want to see that a little bit as we go along here. Right? If I had done the copy, I did an S, and if I do a tab, I have that. By the way, you can do a Control D and see what the matching files are. And it matches almost everything that was in there except for that moduli file or whatever it was that began with an M. So to get to where I wanted to go here, I had to put an extra thing in here. You know, I couldn't figure out what the next character was because it might be an underscore or it might be a D. But then if I hit tab again, now it's got the right name. Now, if that had been the only thing that had been there, it would have not just put this out here, but put a space after it, figuring that, okay, you know, that was the file you wanted, and now maybe you want to type some more arguments after that. In this case, it's stopping right here because it doesn't know whether that's what you want or whether you want a period to become an X. Because this time around, I've got two different files. But that's how we got to that stage and how we got there fast without having to type every one of those characters and make grief. That's line in there again. Without making quite as many typing errors. All right, so I did that to get the one and only file, and then I did it again. In this case, I had to, you know, back up a little bit here, back up over that space that showed up, and put .orig on the end of it. That's what actually got me to the line that looked like this. Right? Write that out, write it out again. Now there's a space there, so back up and put in the new characters that you want to get exactly this line. But that was not very many characters actually have to type to make that happen. Okay. All right, so that's, you know, I'm going to do it kind of fast here in class, but it's all written out here, and you can kind of let that settle into your mind as the days go by. All right, and then next we replace CP with diff to see the diff, and nothing came out if you look at the screen there, but I don't want to get the black line again, so I'm not going to go back just yet. And another possibility that we could have done here is to just do a Control P, and that will put on the screen whatever the last thing you typed was, and another Control P will go back to the line before that, back to the line before that, and so on, right up to the point where you logged out of the system last. And furthermore, it remembers some of your commands from the last time that you had logged on. If you back up even further, you can find out what you did yesterday or last week or whatever. Right, and repeat some of those commands. All right, so now how did we do the editing stuff quite quickly here? Well, I've already explained how that thing works. Right, then when I got into the file, we were already at the right line, so I could yank it and put it back. And that might be worthwhile to just see what actually happens there. So in this case, I'm just going to do a bang V, which will edit the same file that we had before, to go back and find the last command that began with a V, which happened to be VI to this file, and take me to this particular line. Now, you can yank all sorts of stuff here. I can yank an entire paragraph. Let's see what some of the movement keys do in VI. I'm going to use a closed curly bracket. That takes you to the bottom of a paragraph. Another curly bracket, bottom of that paragraph. Curly bracket that way, that way. I can tell it to yank and then give it a movement command like open curly bracket. That would have yanked the entire thing, and then I could put back all of those lines right away. P puts things back. Whatever it was you just yanked. And I'm going to undo this because I didn't really want to do that to this file. And you can also do similar things with words. W moves you on to the next word in a file. And it has its own idea of what a word is here. If you go from punctuation to regular letters, it considers that a word boundary here. Capital W will move you to the next actual word. So if I do a capital W, it looks for some white space and goes to the thing beyond the white space. So lowercase w's are going to find that dash and is going to find the P. B takes you backwards in the same way, but if I do a capital W, it wants to find the next piece of white space before it decides we're at the end of the word. So capital W would take me down to there. Okay, so let's remove what we had done before. Again, if I do a yank and a put, I'm basically at that situation. And then I can insert a pound sign on one of these, and then go to the next one. And, oh, well, actually, I guess I removed the wrong one, but that's okay. Well, let's say we wanted to change it to no. I could tell it to change C, W, change the word. And it tells you it's going to change from here to whatever character used to be there, and you can put in any new thing that you want. In this case, I'm doing no. But we're just going to leave that, that alone. And since I screwed up all sorts of stuff, I'm going to quit without saving any of these changes. So we won't see my bad end. All right, so that's what's going to be discussed in the next part of the file here, if I can get a non-frozen screen again. Okay. All right, so we already talked about yanking P there. There's a lowercase p and an uppercase p. Whatever line you're on here, if you yank an entire line, the lowercase p will put it below the current line, capital P will put it up above the line. Now, wherever you happen to be on that line, if you do an I, remember we talked last time about what I and A do. I inserts after the cursor, or before the cursor. A appends right after whatever character the cursor is blinking to. And there's also a capital A and a capital I here. Capital I goes all the way to the end of the line, beginning of the line, and capital A would take you out past the end of the line. You want to just add the end. You don't have to space all the way over there. Just do a capital A and you're there. If you're in the middle of a line and you want to start at the beginning, capital I takes you to the beginning. Actually, it takes you to the first non-white space character if we wanted to be technical, but you can work it out. Okay, so we want to do an insert, and I wanted to put that pound sign there. Right? And I just escaped out of that. I'm now out of insert mode again. Okay, so we commented out one of the two lines there, and then a J moved me down to the other line, the copy of the line. I did a W here to move to the next word, and I told it I was going to change that entire word. Right? And that the capital C changes to the end of the line here. And we had permit or passwordless login, I forget what it said there, whatever we had in the notes up there. But I wanted to put in these three characters and then escape to get out of change. And then it was time to save the file. Right? And ZZ is the fastest way to save it. You can do a :W to write out the contents and then :Q to quit, but just plain old ZZ works. You know, these two fingers here gets that job done quite quickly. Right? So what we did in that entire file, once I got into VI, I typed like 14 characters or something or other, and we were done with that. Right? Now, of course, it's going to go slower for you, but you know, as a group, try this and see how these things work. And then when you get a chance, practice using the VI, and if you continue practicing, you get better and better at it. You can really do things quite fast. Now, in the real world, you know, you don't necessarily want to use VI for everything. If you're doing software development, probably you have a really nice editor into your integrated development environment, and then you use that in favor of VI. But if you're doing something like system administration, this pretty much is the right tool to have. Okay. All right, and then as we've seen, we're going to repeat the last command. Bang D would have been good enough to do it, to repeat the diff, and it should show us the changes that are now different from what they were before. First having a ridge file and our newly cloned version that were the same, and now they should give you the differences you've seen before if you did VI. And if something went wrong, well, put back the original and copy it again and try one more time. All right, so the point of making that change was to see what happens now. We have set it up here so that you should not be able to get in, you know, passwordless or whatever as root. Well, it will soon, but it's not quite yet. Right? So you can try this again, and even though you know what root's password is here, it's not actually going to let you to do this. And it sort of silently doesn't let you in. It doesn't tell you what's going on here. You want to let any hackers, try forever to do that without letting them know that they're doing it in vain. All right, so it's still not allowing root logins, but we just changed the file there to tell it that logins should be, by root, should be allowed. Now that didn't take effect yet because SSH is many of the daemons are set up to be efficient. Right? When you start them up, they read their configuration files and then believe that from then on. Right? If you want them to have different behavior, you sort of have to nudge them and say, hey, go reread your configuration file, or, as we're doing here, shut down the SSH daemon and then start it back up again. And each time it starts, it reads the configuration file. Right? So you should find, if you do this, the service, which particular service, SSH, and you could tell it to stop, you could tell it to start, you can tell it to reload, which probably would have been good enough in this case, but I'm suggesting you do the restart one here. And that'll work. Now you do have to do root to do this, of course, right? On Rohan, you can't just shut down the SSH service for the rest of the world as just a regular user. So make sure you've got your pound sign prompt when it comes time to try it. All right. All right, so if you do that, then finally you should be able to get in via SSH as root if you know your password, at least for the moment here. Right, so this time around, now that we've told it to reread the configuration file and take note of the changes that we made, you should be able to get back in. And so that's an important lesson to remember here when you sort of change these configuration files. Probably isn't going to know about it until later. And unlike with Windows, you don't have to just reboot the whole machine, right? That restarts everybody again. But if you have multiple users, like the two on Rohan or whatever, we don't want to kick them all off and then make them come back in just because we're making some change. So within Unix here, you almost never have to reboot when you make a configuration change, unless you're installing a new kernel or something and want the new kernel to run, then you have to shut down the old kernel to make that happen. But most of the time, you just restart the appropriate daemon, and you're running continuously. All right. All right, so now if you do this, that's fine. Now what if it had failed here? Well, you'd still have that %sign prompt here, right? You're still root, you could fix things, right? Whereas if you had, not been root anymore, and we did something that, meant you couldn't get back into root again, well, that would then be a problem, right? We'd have to get a DVD or something perhaps to fix that. So whenever you're making potentially catastrophic changes, make sure you've already got an extra root shell open so that you can investigate things without running into a whole bunch of problems. Okay. Now, here's one of the places where we really can make lots of mayhem, because we're going to edit the password file. Right? So if we do this wrong, maybe nobody can log in at all until somebody comes in and gives you a better copy of the password file. All right, so VIPW, as we mentioned, we've seen a little earlier in the notes, is a thing that we would use to edit this file safely, okay, so that we don't have two administrators trying to make changes at the same time, and there are some sanity checks for not having the correct number of fields on a line or something like that. Okay. So like we did just before, it's an important system file, create an original copy that we know works. That way, even if we do completely screw it up and have to go back and put a DVD in there and mount the file system, we don't have to try to fix whatever went wrong with our mangled password file. We can just move the password orig back to on top of Etsy password, and then we're back in business without having to worry what edits got us into trouble. Right? So we have something that works right now. Keep a copy of it. Again, we'll find a safer way to keep copies in Lab 2. All right. Now, by the way, if you edit this file, when we get to doing the VIPW stuff here, We had seen earlier on in the lab that loser had been the last line. We saw that when we compared that to what was on the DVD thing, right, which had a user called mint as the very last line. And since on our actual disk drive, we had a guy called loser. But since then, we brought up the SSHD daemon here, installed some stuff, it did some configuration, and one of the things it did was create another little login into the password file, and it just tags these things onto the end of what had been there before. So it's no longer the last, loser is no longer on the last line. There's this new guy that we had put in here, and it's not something you had done by typing. It's something that one of those configuration packages changed. Okay, all right. So now we're going to add some other accounts here. And yeah, again, you could do you do a VIPW here to edit the password file, just those 4 characters and enter is enough to do it as root. And then you can search for the account called loser, and that'll take you to the right line. It's probably next to the last line at this point in the lab. And if we wanted to get rid of that, DD would make it go away. But that yanks it into the buffer there. Whenever you delete something, that becomes the thing that goes into what's called the unnamed buffer. If you use a P, it would put it back. Okay? So this is an easy way to swap those 2 lines. That means it'll go underneath the SSHD line rather than where it is right now, on top of the SSHD line. So it's fairly easy to move things around within VI, just make them go away and put them back. I'm often more careful about this rather than deleting it and putting it back, because if you do some other little changes there, maybe you put something else in the buffer and it's wiped out the other one. Often what I actually do is yank the line, put it in a second time, and then go back and remove the old line that I had. Right? So if you're cautious, you might actually want to do it that way. But this is clearly the faster way to do it. All right, so you might want to put back another one, do another P, and it'll take whatever's in the buffer, which was that loser line, and put it down there. And then you can go in and edit things here. Change the first word, then change the third word, and so on. Or you can just type a new entry. I'd go into insert mode, hit a carriage return, and put this information in. Okay, so you're at this point starting to create an account for me so that I can log in to the machine that you're administering. And there's 7 fields in these things, right? The first one is the human readable name that people would use. This is where the password normally would go, but I think we discussed this last time. That's kind of a security flaw because this is a publicly available file here. And if people can see the encrypted gibberish, they can, bang on it for days and try to figure out what the actual passwords were. So we store these in a file that most people can't see. It's called the shadow file, and we'll have to mess with that in a little bit as well. But this is the important number here. This is what you're known to by the machine. This is user 1007. Okay, so that's what I'm going to be on each of these machines here. And it happens to be what I am on Rohan as well, I believe. And then this is my group number here, 9999. So you may recall there's 3 permissions fields for files. One is who owns the file, the number of the owner. The next one is the number of what group it's in. And stuff that I create by default will be in group 9999. And then there's permissions for the rest of the world that don't match the user or the group. And next comes between this colon and that colon, the GCOS field here, which has personal information essentially. If you do a finger of a particular user here, it'll come up and say who they are in real life, etc. It'll use this first thing here to say what that is. And we could have typed out John Carroll here, but if you use an ampersand, it's just going to use that line there with the first letter capitalized. So that works fine. And that, by the way, is going to work for most of you on your usernames, unless your last name is more than 8 characters long, and then it's not going to do the right thing for you. Okay, and between the commas here are other subfields here. When you do that finger information, it'll also list, if there is a line here, where your office is, and so we'll put in my office, and then there's a phone number and so on. there's office and home phone numbers here, but we'll stick with just the office one for this, and nothing for home. All right, next field here is where the home directory is going to be. Right? When you log in, you're CD'd to one particular place. The SSH daemon that lets us log in here, or the XDisplay manager that lets you log in, looks in the password file for whatever username you had here, and it will start up this particular shell and put it in this spot here. So that's where that shell begins life. You can CD to other places, but that's always where you start, in your home directory. Right? So we have home directory, and then what the user's preferred shell is. What shell should we be running when they successfully log in? All right. Okay, so try putting that one line in there and then do a diff here and make sure you don't now have 3 different lines, or you threw away some other lines or did something other odd. Okay. Now, by the way, one of the reasons we don't want to use just Pico or Netted or something like that, because some of those things kind of, in a friendly way, if you have a line that goes past 80 characters here, they'll break it up in the middle. And for us, it would probably be right there. They put that part on one line and this rest of the stuff on the next line, and now we have a broken password file if you were using a goofy editor. Yes?
That actually could be fixed using Pico-W.
So with the, say again, dash
-W.
-W, it tells it not to do that.
Right.
Okay, all right. Yeah, so the default is it assumes you're typing, your term paper or whatever, and it's going to make it look nice. Okay. All right. All right, well, that's all well and good. We've said where my home directory is, but there is no directory there just yet, right? So you're going to have to make a directory here. And if we use the -P option here, this says, hey, if there wasn't something already called /home, well, make that first, and then make this afterwards. Right? So we have really long path names here. You can use the -P and have it make a whole bunch of directories all at once. Be a little bit careful with that, because if you misspell something like HOM here, well, it will make an HOM directory, and then it'll make this other stuff, and now you have a whole bunch of stuff in the wrong place. Right? So in our case, there already is something called /home. I could have said just make dear home Carol, and that would have worked fine here, but now I get a chance to talk about what -P does for you with names. And now it's root that did that, so by default, root owns that thing, and you can't write on stuff that root owns unless they give you special permission. So we have to change the ownership of this thing to this particular username. And what are we changing? You can list a whole bunch of different things out here. In our case, it's just one thing, namely the name of the directory. So let me own my own directory. And the default permissions are probably 700 on that, right? Which means that the user can read, write, and execute, but nobody else can look at it. And we're going to be a little more liberal with it here. So 7 is RWX, so that's for the user. Right? And then I've got a 5 next, that's 101, or read, no write, but execute. So other people can, in the group, can come look at what's going on here, but the rest of the world can't see anything. So people who are in the same group as this can look at stuff. And so that's a typical set of permissions you might want to have. So different flavors. We don't let other people write on our directory here. No one but the owner gets to write, but other people can kind of look around. What does execute mean when we're talking about a directory here? Basically just means you're allowed to pass through that directory. So it is possible to have stuff like --x and still have that be useful. So this says that you're allowed to be in that directory and maybe go on to subdirectories there, but you're not allowed to see any of the file names here. So for this to work, someone would have to tell you what the name of a subdirectory was, and you could CD down through home Carol and get into a subdirectory as long as you already knew the name. Because you don't have read permission to do an ls and see what the names actually are. Okay, so that's what X does for directories, right? For regular files, it's just execute permission, right? Everybody in the group could execute that thing if it were a file, right? But the rest of the world could not. All right, and then I think we get the group creates things and puts them in the bin group. GID number 3, but we're going to change it to my group number as well. All right, so that gives me a reasonable work environment. And once again, you don't have to type all of that stuff. Right? You can do just this, right? Tilde Carol means the home directory of Carol, and as long as we did the password thing first, which said where my home directory was, right? That was field 6 of that file. All you have to do is type that. And so that's basically all we need to do for the first line here. And now we have the exact same thing sitting out here for the second line. So all I have to do is type Schoen and Carol, and then I can use that. Exclamation point $sign means take the last word from the last command and pretend I typed all that out. So I don't have to type home Carol again here, or even tilde Carol. It just will go and get that and pretend that I have put it there. And it's that same guy that you're going to use in each of these cases. So 2 characters rather than 8 characters or so, or even more if you typed it out with a slash. So I recommend trying to take these shortcuts. Now it'll tell you what it's about to do if you do that. And the good thing with TCSH, after you do this, you can hit the tab key, and it'll expand that out into home Carol, etc., so you can see what it really is. Actually, let's try that on Rowan here. You can see what I mean. All right, so if I say ls tilde, well, let's do an echo tilde Carol. Okay, and now let's do ls, and now I'm going to do that. But now if I hit tab, it'll tell me what that was. Right, so rather than, if you're worried about it, you can see what it's about to do. For example, I can do a bang E, do the last command that began with an E. I'm not sure what that is, but if I hit tab, it'll tell me what that was. Right? So often that's a good idea to find out what it's really going to do rather than assuming you know. All right. Okay. All right, so if everything worked right, you should see something along these lines as the names, right? You get the RWXs, etc. If it was a regular file, you just have a dash out here. A directory does a D. If it's an in pipeline, you'd get a P there. If it's a character special file like dev TTY, you have a C sitting there. So there's lots of different things that tell you what that kind of thing is. Soft links would have an L sitting there. All right, now, depending on what we had told it at the beginning, here when we installed it, where we lived in the world and things like that, it may have adjusted how the ls command was actually going to run. Right? In some areas of the world, they really like to see dates that way. Right? So depending on what language you tell it to use here, what protocols to use, you can get it to do things in slightly different ways. So for example, you could try that, for example, and that would then give you a different type of formatting on it. All right, so if you get it one way rather than the other way, this would probably be enough to fix it. Not that we care all that much. Both types of dates are easy to read. But that's the kind of tricks you can do to make that work. Now, this is what you would say if you were talking to Bash or SH. To say the exact same thing, you do it this way for shells like CSH and TCSH. They have different syntax for setting environment variables. All right. So now if we have set this stuff up right, we haven't quite yet. That probably won't go anywhere for us because we don't have a password set up. We haven't changed the shadow file just yet. All right, so but give it a try and expect it to fail. Right now, on some versions of Unix, they just sort of let you in if you haven't specified a password. Okay, you want to let people in without any password, but that's generally a bad security decision to make. So it kind of does that right. All right, so we're going to run VIPSPW again, but with the dash option, which now means don't edit etc password, but edit etc shadow. This is where the encrypted passwords are actually stored. Now, there is no decryption utility here. There's no good way to do whatever this complicated stuff and undo it. You can't look at that pattern and figure out where it actually came from. The only way to crack passwords is to basically try a bunch of different ones. Try every word in the dictionary and see if any of them look like, what this gibberish is here. So that's why, it used to be they just had these in the clear. It didn't look like anybody could figure these things out in any reasonable amount of time, but then computers got a lot faster. Right? So we hide that information these days. Okay, so now we'll go down to close to the bottom here, find that loser line, copy it into the file again, right, with a yank and then put it back at the bottom there. And if we just leave it like that, if you change loser to Carol on that new line there, okay, you now have a file where Carol and loser have the same password, so we know what that is. That was